Hi everyone, today I'm looking at question 16 of the 2012 HSC Extension 2 exam. So for this exam, question 16 was the final question, and it's made up of 3 parts, part A, B and C, and then each of those has its own subparts. So I've been asked to help out with the whole question, so what I might do is in this video I'll focus on part A, part 1, and then I'll look at all the other parts in separate videos. So part A, part 1, asks in how many ways can M identical yellow discs and N identical black discs be arranged in a row? So we're dealing with combinatorics here, so let's take a look. So this is what we're dealing with. We want M identical yellow discs and N identical black discs in a row, and I think the key to this is noting that our discs are identical, so M of the identical yellows and N of the identical blacks, and they're in a row as opposed to, say, in a circle where things might change a little differently. But in this case, actually, there's a few ways you can think about it. I think maybe what you'd call the standard way or the typical way would be simply to say that the number of ways you can arrange this would be equal to, well, the total amount of discs that we're arranging is M plus N. So you'd say M plus N factorial. But noting that a whole bunch of the discs are identical, M of the yellow ones are identical and N of the black ones are identical, just leaving it like this would overstate it, because the identical nature of the discs means that you know, regardless of which one you put where, it's effectively the same thing because they're identical. So there's actually a lot less ways you can do the arrangement, given that you can't distinguish between a whole bunch of the discs. So the way we reduce this result is to divide. So what we do is we divide first by M factorial, and that's how we take account of our identical yellow discs, and then also by N factorial, because that's how we take account of our identical black discs. And so after doing that division, we've now reduced the number of ways by the necessary amount, so that we're effectively not double counting any arrangements that are effectively the same. And that's pretty much, I would argue, a valid answer. I don't think you need a lot of working. It's a 1-mark question at the end of the day, so I doubt those who would be marking this question are looking for much more than this. So if you can wrap your head around that, I'd say that would be a fine way to answer the question. But admittedly, there's probably plenty of students who perhaps this isn't instinctively what they might think of. You might not naturally be able to come up with this. And so what I might do now is just lay out an alternative approach. It's got a few more steps, so it might take you a little bit longer, but you may find it a bit more intuitively appealing. And so if it's a way that makes more sense to you, maybe that's the way you would go with if you had to answer a question like this. So what I might do for this alternative, to start, I might just kind of draw up just kind of what I'll call spaces. So, you know, we've got a whole bunch of spots or spaces that we want to put these discs in. And the tricky thing about this question is we actually don't have the number because we're dealing in generic M and N. So I'll just kind of put some dots, and essentially the number of spots that we've got to put our discs is we've got M plus N spots. And so you can think of this question as simply, well, in what spots can we put all of our discs? How many ways can we do that? And so we're effectively arranging in a row like we're being asked. Now, one way you could go about this is first throw the yellow discs into a bunch of spots, and then throw the black discs into whatever spots are remaining. And so if you think about it from that perspective, you could say for the yellow discs, how many ways could they be put into various spots? Well, there's M plus N spots for the yellow disc to go into, and there's M of them that we want to place in, and because they're identical, we use the combination. The order doesn't really matter. You know, a yellow disc in spot 1 and 2 is the same as a yellow disc in spot 2 and 1. You know, the order doesn't matter. So we say M plus N C and then M. So that's the number of ways we can put our yellow discs in. Now once that's done, the number of ways we could put in the remaining black discs would be, well, there were M plus N spots, but M of them we've taken up. So now there's M plus N minus M spots left. And again, we care about combinations. And now we're looking at putting N of those of the black discs in those remaining spots. So if we kind of now take this and get it into factorial format, what we'll see is that we end up with the same result. So with a few extra steps of working, we'll get to the same place. So as I kind of mentioned, if this is a approach that makes more sense to you, feel free to go for it. So if I start with the yellow disc, we can say M plus NCM. Well, we just use our combination formula to get that into factorial format. So it's going to be M plus N factorial divided by M factorial times M plus N minus M factorial. So that's basically just using the generic rule NCR is equal to N factorial on R factorial N minus R factorial. That's the rule I've used, but I've just got M plus N instead of N by itself and M down here instead of R. So these M's will cancel and we end up with M plus N factorial on M factorial N factorial. Now that's interesting because that is the result. So what's going on with this bit here? Well, maybe you noticed that M plus N minus M would just be N Cn. NCn is just going to be equal to 1 because you know, anything C the same number, there's just one way. There's one way to put n things into n spots. So therefore, the number of ways that we get to with this technique is just equal to M plus NCM times NCN, which equals our M plus N factorial on M factorial N factorial, what we just worked out there, times 1. And anything times 1 is just what we're dealing with. So that then matches perfectly with the first approach I went through, the kind of very direct approach. So clearly a lot more working, but you know, if you get to the right place at the end of the day, I think that's what's most important. So yeah, hopefully one of those options makes sense to you and it's something you could work with if you had to tackle a question like this on your own. So there you have it for 16A part 1. So in the next video I'll take a look at part 2 and yeah, tick boom.